Can AI really learn from itself? Dive into the world of recursive language models.
We look at today's top AI models and they seem, well, almost magical, right? They can write code, they can create art, hold these incredible conversations. But behind that curtain, even the most powerful AI has a secret, and honestly, a pretty shocking limitation. So let's get right into it. And it really all boils down to this one question. If you give an AI a short little paragraph, it's brilliant, but give it a whole book, a massive legal file, or an entire code base to look at, and its performance doesn't just get a little worse, it can completely fall off a cliff. So what's going on here? Okay, so the heart of the problem, it's all about memory. And researchers, they've actually got a name for it, context rot. And this isn't some tiny bug. It's a flaw that's like baked right into the DNA of how these models currently work. And it's been the biggest roadblock to unlocking what they can really do. All right, here's a great way to think about it. Imagine a brilliant detective, right? But you force them to solve a huge, complicated case using just one tiny little notepad. Every time a new clue comes in, they have to scribble out an old one. They just run out of space. They get overwhelmed, they forget important connections, and they miss the big picture. What we've always wanted is to give that detective access to the entire library of evidence and the ability to navigate it all without getting lost. So let's really nail down this term from the MIT research, context rot. And listen, this is key. It's not just about the AI getting a little bit worse. It's that its ability to actually reason can completely fall apart as you give it more and more complex information. It's this crazy paradox where the more you tell it, the dumber it gets. And look, this isn't just some abstract idea. When researchers put a top-tier model to the test, the results were, wow, they were really stark. If you ask it to find one single fact in a long document, the classic needle in a haystack task, it does okay, pretty well. But ask it to pull together information from all over the document, and its performance takes a nosedive. Then ask it to do something really complex, like compare different facts scattered all over the place, and its performance just collapses. Totally failed. So for years, the solution seemed obvious, right? Just build a bigger notepad, a bigger context window. But then, a team at MIT had a different idea. They said, wait a minute, what if we stop trying to build a bigger notepad and just change how the detective works altogether? Yeah, the old way was all about brute force. The idea was, let's just cram more and more and more info into the AI's short-term memory and, hope for the best. But as we've seen, that strategy just hits a brick wall. At the end of the day, context rot always wins. So the new idea? It's a total 180, a complete paradigm shift. Instead of forcing the AI to memorize a giant document, what if we let it explore it? What if we gave it tools to navigate the information, just like a person would? And this incredible new approach is called a Recursive Language Model, or RLM for short. So an RLM doesn't look at a massive 10 million word document as this one huge thing it has to stuff into its brain. No, it sees it more like an external environment. It's like a database that it can poke and prod at by writing and running its own code. And this, right here, this is basically the magic trick. Instead of trying to swallow the whole book in one gulp, the RLM just loads the book as a variable in a computer program. So the AI isn't memorizing the book anymore. It's being handed the tools, the code, to look up any page, any chapter, any word it needs, exactly when it needs it. So what you get is an AI that's basically become its own programmer. It's writing code, on the fly, to solve its own memory problem. It's pretty wild. Let's break down how this actually works. Okay, the process here is just so smart, so elegant. So first, the AI takes a quick peek at the document, stored as that variable, just to see what it's dealing with. Then it starts breaking the problem down. It literally writes its own code to search for keywords or slice the text up into smaller, more manageable pieces. Now, if it hits a really tricky part, it does something amazing. It delegates. It calls up a fresh copy of itself to focus only on that one little piece. That's the recursion part of the name. And then finally, it acts like a manager, gathering up all the results from its code and its little sub-agents to build the final complete answer. And get this, this isn't something they explicitly programmed it to do. The AI figures these strategies out on its own. Look on the left here. You can actually see it writing Python code, using things like regex searches to scan for clues like a pro. And on the right, you see it delegating that hard thinking to those recursive calls and then programmatically stitching all the answers back together. It's not just a detective anymore. It's a researcher and a project manager all in one. Okay, so that all sounds great in theory, but the big question is, Does it actually work? Well, let me tell you, the results aren't just good. They are absolutely jaw-droppingly staggering. Seriously, this is where it gets really exciting. All right, remember that super complex task, the one where the regular model just completely bombed? Right, a top-of-the-line model scored 0.04%. That is, for all intents and purposes, zero. Useless. But when they ran the RLM version of that exact same model, it scored 58%. Think about that. It went from complete and total failure to a solid B-. That's not just an improvement, it's a monumental leap. And this chart really just says it all, doesn't it? I mean, you can barely even see the bar for the original model. It's just a sliver. The RLM approach isn't just a minor tweak. It is a fundamental game changer, unlocking a level of reasoning that was, honestly, just impossible before. So what's the new limit? How far can this go? Well, the researchers threw prompts over 10 million tokens long at these RLMs. To put that in perspective, that is like asking it to read Moby Dick more than 15 times over, and it still performed incredibly well. The detective's little notepad, it's gone. It's been replaced by the entire Library of Congress. You know, a breakthrough like this isn't just some cool thing for researchers to talk about. It fundamentally changes the game. It changes what we can even ask an AI to do. We're talking about a whole new frontier of possibilities here. Just think about it. Imagine an AI that could sift through thousands of legal documents to find that one critical clause from 30 years ago. Or what about an AI that can read an entire company's codebase, millions of lines, and find a tiny, subtle bug that's been hiding for years? This could massively speed up scientific research, cross-referencing thousands of papers in an instant. It could even write a really long, really complex novel and actually remember all the plot points from beginning to end. This is the stuff that used to be pure science fiction, and now it's starting to look real. And as the researchers themselves put it, this isn't just some one-trick pony. They call RLMs a task-agnostic paradigm. That's a fancy way of saying it's a general-purpose upgrade. It helps with long documents, and it just makes the AI better at complex reasoning, period. It's a fundamental upgrade to the AI's entire operating system, to how it thinks. So, this incredible breakthrough leaves us with a really big, really exciting question. For pretty much the first time ever, an AI's ability to tackle a problem isn't limited by its memory anymore, just by its raw intelligence. So, now that the AI can finally read the whole library, what's the first thing we should ask it? What are the biggest, hardest, most important problems we should point it at?
Like, share, and subscribe to my channel for more AI insights. I'm the Code Architect. See you soon.